My name is Melanie and I am a student from Radnor High School. Today I will be giving a presentation on GPR75 and the obesity crisis. So first, a little bit about myself. I am a rising junior at Radnor High School. I have interned at the University of Pennsylvania and am a current intern at New York Medical College, where I am doing a research project on GPR75 and obesity. I serve as a youth ambassador for the National Foundation for Cancer Research and hold leadership in a couple of clubs within my school. On the right is a photo of me working in the labs, and in the future, I hope to pursue a career in biology or biomedical sciences. So first, what is obesity? Obesity is defined as excessive fat accumulation that presents a risk to health as defined by the World Health Organization. This disease occurs when an individual has a BMI greater than or equal to 30, and obesity is something that can affect both adults and children in underdeveloped and developed regions. Obesity is associated with various major health concerns, such as high blood pressure, heart disease, and even certain types of cancer. In some cases, obesity is even known to cause premature death. So what is its effect on global health? Well, obesity is a growing global health epidemic as declared by the World Health Organization in 1997. Today, 2 in 5 adults and 1 in 5 children in the U.S. have obesity. Countries worldwide have experienced an extreme growth in obesity rates, especially within the past few decades. On the right is a map of the world, which shows the share of adults who are overweight or obese, and clearly in some countries, the amount of adults who are overweight is extremely high. There's also an economic impact of obesity. For example, the average obese person costs 36% more in medical care than healthy weight individuals. Moreover, the U.S. healthcare system pays almost $173 billion annually for individuals with obesity. Clearly, obesity is influencing overall life quality and life expectancy. There have also been a couple of scientific breakthroughs when it comes to treatments for obesity. For example, YOLO Pharma's pill named Sana, Novo Nordisk's amycretin treatment, and GPR75 and 20 heat targeting drugs, which is what I was looking at in my own research and what I'll be discussing later in this presentation. So what are GPR75 and 20 heat? GPR75 is a G protein coupled receptor found in cells throughout the body, for example in fat tissue cells. 20 heat is the ligand to this receptor and is derived from arachidonic acid. 20 heat is also elevated in individuals with obesity and metabolic disease, as this signal transduction pathway causes increased fat storage as well as greater fatty acid uptake. What's interesting is that GPR75 knockdown mice have been shown to resist weight gain even on high-fat diets. A knockdown is essentially when a specific gene is silenced or temporarily inhibited or reduced, and in this case that would be the GPR75 gene, so the receptor wouldn't be fully working and its function would be reduced. Currently, drugs are also being developed to inhibit the binding of 20 heat to GPR75. So here is a diagram of the GPR75 signaling pathway. Here we have the receptor GPR75 and its ligand 20 heat that binds to it. This pathway leads to the production of calcium ions, and what these calcium ions do would be phosphorylate and create fatty acid transport proteins. These transport proteins will bring in fatty acids into the cell, causing metabolic disease and obesity. AAA here is one of the drugs that we tested and looked at to inhibit 20 heat from binding to the receptor. So in our trials with GPR75, I measured the amount of calcium ions and the calcium ion concentration in GPR75 knockdown cells, so when the receptor isn't fully functioning, in cells with GPR75 but without 20 heat, with 20 heat and the receptor, and with 20 heat and a drug to inhibit. The vehicle that I used was ethanol, which normally causes a response in calcium ion concentration and acts as a control for this experiment. I also used a dye that would mark the calcium ions so that we would be able to record the concentration in relative fluorescence units. So what we found is truly groundbreaking. The production of calcium ions is nearly tripled with the binding of 20-HEAT to the receptor, meaning greater fatty acid uptake from the produced fatty acid transport proteins. However, certain drugs have been able to inhibit this increased production of calcium ions, for example, AAA, as I mentioned earlier. What's also interesting is that knockdown GPR75 cells have also inhibited this increased production, and both of these have brought the production of calcium ions all the way back down to the original vehicle response, and we have seen this consistently and repetitively throughout all of our trials. So here we have the results from our experiment, and it shows the calcium ion production in wild-type and knockdown cells. So the wild-type cells, or the vehicle, are all the way down here, which clearly have a lower calcium ion concentration than with the 20-HEAT binding to the receptor. There is a huge increase in the calcium ion concentration, which, as I mentioned earlier, would cause greater fatty acid uptake. However, with knockdown cells, even with the binding of 20-HEAT to the receptor, the response is brought all the way back down to the vehicle response, showing that without the GPR75, the calcium ion concentration is reduced. So what is the future of obesity treatments? Well, drugs may be able to find a way around just reducing appetite, as scientists are targeting new pathways and processes within our bodies. Certain companies are testing GPR75-focused obesity treatments, and in the future, we could see the creation of more affordable and safe drugs in different forms rather than just injection forms. New treatments would obviously help millions of lives worldwide who have this disease. So to summarize, obesity is a major global health crisis affecting over 1 billion people across the world. New treatments for the disease have been targeting fat storage and burning over just reducing appetite, and GPR75 targeting drugs could have a major impact on the future of obesity treatments. These were my references. And as for acknowledgements, thank you to the Global Health Leaders Conference at Johns Hopkins University for the opportunity to speak today. Thank you to Mrs. Trazo from Radnor High School for your support in my studies and participation in the GHLC. And finally, thank you so much to Dr. Garcia from New York Medical College for your continuous support and help with my research. Thank you all so much for listening, and I hope you enjoyed my presentation.